Welcome everybody to this webinar on warm homes and heat pumps. We're very glad to have you join us this morning to talk about this crucial topic about how local authorities and social landlords can deliver the highest quality heat pump installations. My name's Will Rivers. I work at the Carbon Trust. So this is actually the fifth webinar in our series for the public sector on overcoming barriers to net zero. So there's previous sessions which you can watch on our website around decarbonising the built environment, renewable energy, heat networks, and net zero carbon targets. And do join us on the 1st of October for the last in the series on place-based net zero targets. So the impetus for this webinar in particular came from a lot of the work we're doing with local authorities and social landlords on the challenges of deploying heat pumps in their housing stock. I think there's really strong recognition out there that from an environmental perspective, deploying heat pumps at scale is absolutely critical to reaching net zero. And more than that, the lowest cost way to heat a home in 2025 is via a heat pump. And in fact, a heat pump operating at say 350% efficiency when paired with a time of use tariff could potentially halve fuel bills for somebody compared to a gas boiler in the best cases. So increasingly kind of seen as something which can have a really good impact on fuel poverty as well. The problem that we have at the moment, and that we're going to talk about today, and that I know a lot of you will be experiencing, is that not every heat pump installation is up to that standard. And so there's very legitimate and understandable concerns out there about installation quality. And when you consider that any heat pump operating inefficiently is potentially exacerbating fuel poverty for a tenant, it's a really, really critical concern. So today, what we really hope to do is give you the valuable insights and practical steps that can help you on that journey to improving heat pump quality in your projects and programs. By the end of the session, we hope to have given you insights on what distinguishes good from bad performance, and some practical steps that you can take away to start hopefully implementing in projects and programs. We've got a really fantastic lineup of speakers for you today. So pretty soon I'm going to pass over to Matt Aylott from the Department for Energy Security and Net Zero. Matt is the Electrification of Heat Policy Lead. He's going to be talking about warm homes, local authorities and heat pumps. We're then going to pass over to Glyn Hudson from the fantastic Open Energy Monitor to talk about some of their insights from monitoring hundreds and hundreds of heat pumps on what drives good and bad heat pump performance. We're then going to hear from Matt Jones from Bristol City Council, who's going to give a very unvarnished view on some of the experiences they've had, the quality issues they found, and critically what they're doing about it to try and improve performance. And then Jack, my colleague at the Carbon Trust, is going to try and synthesize some of this into 5 practical steps that you can take away. And we're going to try and do all of that in an hour. So it'll be really good going if we can do it. I should just say as well, I can only apologize for the lack of diversity on the panel. It's a serious point that an all-male panel is something that we very typically try and avoid. So I thought it's just mentioned that this is the exception rather than the rule. Quick housekeeping. So we're hoping this will be an interactive session. I'd encourage you to use the chat function. And it'd be really great if you're happy to just introduce yourself in the chat there now. Would be lovely. And I'll be posting a few questions throughout to try and get your input as much as possible into this, because I think everybody on this call would recognize that none of us have all the answers, and this is very much an open dialogue about how we collectively try and drive up standards. This webinar is being recorded and will be published on the Carbon Trust website. So without further ado, I'm going to pass over to Matt Aylott from Department for Energy Security and Net Zero.
Hello, everyone. So yeah, I'm Dr. Matthew Aylott. I'm the Electrification of Heat Strategy Lead at the UK Department of Energy Security and Net Zero. I've been working on the electrification of heat for nearly the last decade, and in that time have delivered various policies and overseen major trials and research programs looking at the performance and optimization of heating systems. So I'm going to talk through in 10 minutes the role of local authorities in delivering their heat pump rollout and some of the actions that we're taking as part of the Warm Homes Plan to accelerate the deployment of heat pumps at scale. Next slide, please, Will. So just as a starter for 10, why is government interested in heat pumps? Hopefully I'm preaching to the converted somewhat, but I think it's worth emphasizing that we believe that heat pumps are central to decarbonising our homes, given that home heating now accounts for around 18% of the UK's greenhouse gas emissions. And heat pumps have the potential to cut carbon emissions by up to 70% compared to a gas boiler based on current carbon intensity of the grid. Aside from that, they also have a major role in improving air quality. So, for example, research has found that gas boilers are now the biggest source of air pollution in central London. They're also very prevalent in terms of increasing particulate levels inside the home. So gas cooking is one of the major causes of increased respiratory issues and cardiovascular disease. Studies and trials, real-world performance have shown that heat pumps can be a cost-effective option for decarbonising our homes. On average, with an effective heat pump time of use tariff, a consumer could save up to £100 on their bill compared to a gas boiler. But of course, costs are very variable depending on usage, performance, etc. Next slide, please, Will. So what's the role of local authorities in delivering the heat pump rollout? Well, there are currently an estimated 600,000 heat pumps installed across the UK. Last year saw record growth in the number of heat pumps installed, a 63% increase on the previous year. We've also seen record-breaking numbers of installers being trained. Local authorities have a really key role in that rollout. Since the start of 2022, around 40% of heat pumps installed under government schemes have been delivered through schemes specifically targeted at low-income groups, often delivered by or in partnership with local authorities. And as you can see from the electrification of heat tracker that Ambient produce, there are significant volumes, particularly under the energy company obligation, being delivered, but increasingly under schemes like the Social Housing Decarbonisation Fund as well. Next slide, please, Will. So a question that we often get asked is, has the local authority-led rollout of heat pumps been a success? Well, I think that's a matter of perspective, but generally speaking, yes, we would say it has. There are lots of great examples and case studies of successful heat pump delivery across numerous local authorities. And as an example there, from Fareham of Fred, who got a heat pump installed under the Warm Homes local grant, and it reduced his bills by nearly 50%. That's obviously just one example. Heat pumps installed by or in partnership with local authorities have saved households millions of pounds in heating costs, reduced air pollution, improved health outcomes for vulnerable consumers. Importantly, they've also created and sustained thousands of very highly skilled jobs in the supply chain. And of course, they've cut carbon emissions by millions of tons. But, next slide, please, Will. But there, of course, have been cases where there have been issues with the quality of the installation or the performance of some of those heating systems. There are a number of different factors which can contribute towards poor performance of heating systems. The three primary ones that I've listed here, and I hope that Matt and Glyn will pick up on some of these in their presentations, but one of them being insufficient lagging or insulation on pipework, so a relatively easy thing to check and to remedy. As you can see there from the figure on the right-hand side, there is very high heat loss coming from those poorly insulated pipes. And this is an example from a trial that we ran a couple of years ago. You also have undersizing systems, poor hot water management, or flow temperatures being set high, which obviously increases energy consumption and leads to higher bills. And one of the big ones that we've identified and found from trials like the Electrification of Heat Demonstration Project is weather compensation curves being set up incorrectly, leading to things like cycling. So that's the constant switching on and off of the heat pump, which increases wear and tear and leads to higher energy bills. And this really demonstrates the need for a strong focus on the initial design of the heating system, good quality control, good system handover, which is really important for things like hot water management, making sure that people aren't hitting that boost button and killing the performance of the heating system. And of course, effective monitoring of the system on an ongoing basis. Well, next slide, please. So what are we doing to improve the performance of heating systems? Well, we've taken steps alongside MCS to improve outcomes for consumers. So earlier this year, we provided MCS with access to consumer data so they could reach out and call every single consumer who receives an MCS certificate after a heat pump installation. And that's part of a broader effort to enhance consumer protection and ensure consumers are satisfied with the quality of installations. MCS have also provided a single point of contact for customers to escalate complaints and better guidance on how to escalate to an alternative dispute resolution service. But of course, we want to stop issues from arising before they need to be escalated with MCS. So we've been putting a lot of effort and funding into training. So we funded nearly 10,000 places on training courses through the Heat Training Grant. We've also launched with the Department for Education, the UK's first dedicated low carbon heating technician apprenticeship last year, around this time last year. And we're also working very closely with industry to improve the quality of training provision. So one thing we've often heard is that you can't become competent with a 3-day course. Absolutely, we want to double down on making sure that training is of sufficient quality and delivers that practical hands-on installation training to ensure that installers are better equipped to deliver high quality heat pump installations. Next slide, please, Will. So what's the future role of local authorities in the heat pump rollout? Well, most of you, I hope, will have heard of the Warm Homes Plan. So that's the government's flagship programme to upgrade 5 million homes over the next 5 years with a combination of insulation, solar panels, batteries, and of course, low carbon heating, primarily heat pumps. The government has committed as part of its spending review £13.2 billion or up to £13.2 billion to fund the plan, which is the biggest investment in home upgrades ever made. We've started delivering some aspects of the plan, but our overarching Warm Homes Plan strategy will be published in October. And this strategy will set out our approach to regulation, grant funding, and wider enablers to scale up heat pump deployment. Next slide, please, Will. And just in terms of what that plan will look like in a bit more detail, so I don't want to give away too much, and I probably can't give away too much, but I'll tease some of the contents of the Warm Homes Plan. Primarily, what we want to do is create the right market conditions for heat pump deployment to grow and for heat pumps to prosper. So we'll be implementing regulation to provide that long-term certainty and clarity to the market to plan, invest in low carbon heating technologies. We'll continue to provide financial support, so fully funded installations for those on lower incomes and affordable solutions for everyone else. But perhaps most importantly, we'll be delivering a package of enabling measures. So that includes driving down the cost of electricity bills, making sure that installation processes are simpler, that we have effective training and skills amongst the supply chain and workforce, and we have informed consumers who are able to make informed decisions about the heating systems that get installed in their homes. Next slide, please, Will. So just touching on this, the sort of bread and butter of what we'll be delivering as part of the Warm Homes Plan. Obviously, we have the Future Home Standard, which is coming into effect, which will ensure that all new homes are fitted with low carbon heating. We're redeveloping our energy performance certificate and introducing the new home energy model to replace the standard assessment procedure. We're also raising the minimum energy efficiency metrics and standards for private rental sector homes, and we will be taking action to clarify the role of hydrogen for domestic heating and ensuring that in future low carbon heating technologies, primarily heat pumps, will be the default when replacing a heating system for all homes. To ensure we deliver this, we want to ensure that heating solutions like heat pumps are no more expensive than a gas boiler over their lifetime, and that low carbon heating is installed to a high quality. Next slide, please, Will. So probably most importantly to this group, we will continue to be providing funding for owner-occupiers and private landlords through the boiler upgrade scheme, with increased spending each year out to 2030. But for those on lower incomes, we are funding the Warm Homes Local Grant, £500 million up to 2028, and the Warm Homes Social Housing Fund with Wave 3 covering the period up to 2028. We also have confirmed funding to continue supporting social housing, and further details of that will be announced as part of the Warm Homes Plan. We've also announced plans to extend the energy company obligation beyond April 2026, and our, again, spending review settlement includes further funding to support those households, and especially those in fuel poverty up to the end of the decade. And we'll be laying out the next stages of the obligation in the Warm Homes Plan. Next slide, please, Will. One thing that obviously is very close to people's hearts, and we get chastised a lot, is the high cost of electricity, and particularly the high proportion of levies that are applied to electricity versus gas. We are very much committed to rebalancing gas and electricity prices to make low carbon heating more affordable. It's probably the number one priority for ministers at the moment. We are considering several options for doing this, but our aim is to ensure that households using the lowest carbon forms of heating have reduced bills compared to using a gas boiler. And we will implement changes to prices to ensure that it minimises the cost for those on gas heating. Next slide, please. We also want to ensure that consumers have clear advice, so that's about providing long-term certainty and clarity to consumers. We will provide impartial advice and clear information so they can make informed decisions with confidence. We're also reforming consumer protections to better serve consumers and installers. And we're developing a single access point on Gov.uk for information and advice on home upgrades, so our new front door service. This will link consumers with trusted installers, support and options for finance, as well as providing a single point of access for government support through grants, etc. Next slide, please, Will. And I think this is my final slide. So we will also be ensuring that we have a skilled and resilient workforce. We already have the heat training grant and apprenticeship standards. We're looking to improve those and continue to ensure that installers have access to high quality training in future. We also want to streamline the consumer journey to make upgrades faster, simpler, more accessible. We know that 6 out of 10 heat pump installations are distressed purchases. We want to drastically cut down the complexity and time taken to install a heat pump to try and better serve that market segment. That means doing things like removing unnecessary paperwork, further improving the planning regime, so looking at noise planning standard and maximum permissible noise levels, and streamlining the network connection process to rapidly speed up connections and approvals. So I've very quickly just ran through that in 10 minutes. I think I've just about stuck to time. There will be opportunity for questions, I think, at the end. So I will now hand back to Will.
Brilliant. Thank you, Matt. Really appreciate that. Really great to hear what all the great work that you're up to, especially on rebalancing electricity costs. I know a lot of people will be really pleased to hear about that commitment. And yeah, appreciate the kind of teasers of how the Warm Homes Plan is shaping up, although I know it's still in development and due for launch towards the end of the autumn. Is that the plan? Brilliant. Okay, well, Matt has trailed a few of the things there that that Glyn's going to talk about, but I'm really pleased to hand over to Glyn Hudson now from Open Energy Monitor. If you're not familiar with Open Energy Monitor, Glyn's going to tell you about it, but it's an incredibly well-respected open source platform for monitoring heat pump performance and other renewable energy technologies. So yeah, looking forward to Glyn's insights.
Okay, thank you, Will. Hello, my name is Glyn. Glyn Hudson. I'm one of the co-founders of Open Energy Monitor, and we run a website called heatpumpmonitor.org. Can I have the next slide, please, Will? So heatpumpmonitor.org, it's an open source project to share independently monitored heat pump data. We set it up to help support peer-to-peer learning and highlight what's possible with heat pump performance. Next slide, please, Will. So currently, as of today, we've got 383 systems on the site with live independent monitoring. And these heat pumps have been installed by many fantastic installers all over the country. Most are small independent installers, but there's also some larger companies there as well. And these heat pumps, they're all metered with independent metering equipment. It's the same grade of metering equipment that's used in the RHI and other government trials, and it's fully MID certified. And that system's been provided by us to do the monitoring. So out of those 383 systems, 280 of them have been installed for a period of over 12 months. And you can see the performance figures, speak for themselves. These are we've got some very high performing systems on there, which is fantastic to see. So overall, the SCOP, the seasonal coefficient of performance of space heating, averaged 4.1. The hot water performance averaged 3, and the overall combined was 3.8. Next slide, please, Will. So I'm just going to briefly compare the performance of the heat pumps on Heat Pump Monitor with the performance of the heat pumps from the electrification of heat data, which was the last sort of government trial on heat pump performance. It was a BEIS-funded trial from 2020 to 2021, and they installed a large number of heat pumps with monitoring, 545 systems, and the average SCOP of these systems was 2.9, which is above the MCS minimum of 2.8. But you can see from the distribution there, quite a few of them fell short of the minimum, and that minimum figure, it's a minimum. Heat pumps can do much better than this, and we should be trying to make heat pumps work better than this. But the good news is, I think from the data we've seen, it is possible to install high performing heat pumps without too much difficulty. Should just say thank you to BEIS for making the data from this project available. We've loaded it into our platform and published it on the website EOH, electrificationofheat.heatpumpmonitor.org, where you can easily browse all this fantastic data set of heat pumps, of monitoring data. Next slide, please, Will. So just comparing the performance of Heat Pump Monitor on the left with the performance of the heat pumps from the electrification heat trial on the right. The average heat pump on Heat Pump Monitor has 23% lower running costs compared to the average heat pump in the electrification of heat trial. That equates to around £400 a year saving on the heating bill. So it's a substantial amount. So it's definitely worth trying to do this. And those red lines there just show the cost parity with mains gas. As you can see, not many systems from the electrification of heat were lower cost than gas. That is on a price cap tariff. If on a smart tariff, especially with heat pumps and solar, it is possible for a heat pump to achieve cost savings over mains gas with a lower performance. But obviously, the higher the performance, the easier that is, and the less susceptible the user will be to fluctuations in energy prices. Next slide, please, Will. So let's first touch on the similarities between the high-performing systems we've got on Open Energy Monitor and the electrification of heat systems, which are probably fairly typical of heat pump installations. The trial reported a high level of customer satisfaction. People were generally happy with the heat pumps, and there weren't any significant issues with internal temperature. We pulled the data from Heat Pump Monitor, and we could see that on the coldest day of last year, where the average temperature dropped down to 2.5 degrees over that day, the average indoor temperature from the heat pumps on Heat Pump Monitor was 19.5. So heat pumps keep people warm, and there was that's quite clear, and there was the same outcome from the electrification of heat trial. Next slide, please, Will. Another similarity between what we've seen on Heat Pump Monitor and electrification of heat data is that heat pumps can work in houses irrespective of the property age and insulation level. We pulled the data from Heat Pump Monitor to look at this in detail, and you can see the table on the left here, a range of different age of properties, and there wasn't a significant difference in the performance of the heat pumps in those properties, in the different properties. And the same on the right, we've got a table here showing different levels of insulation in houses, and again the SCOP, the SCOP performance, didn't differ considerably with different amounts of insulation. So I think once you've got loft insulation, good fit in doors and windows, putting a heat pump in should definitely be the next thing on the agenda. Next slide, please, Will. So the key difference we've seen between the systems on Heat Pump Monitor and the electrification of heat systems, which is the main differentiating factor, was poor commissioning. Yeah, Matt touched on this. Basically the electrification of heat systems, almost all of them were running much higher than necessary flow temperatures. So the golden rule with heat pumps is the lower the flow temperature, the higher the performance. That's just physics. So that's something we saw again and again when we were analysing the heat, electrification of heat data. We also saw that there was suboptimal hot water storage commissioning. The hot water was often stored at a very high store temperature with a very low hysteresis. So the heat pump, as soon as a small amount of hot water was drawn off, the heat pump would almost immediately kick in to try and reheat the tank, even though it's still piping hot. And that results in poor hot water performance. Next slide, please, Will. So let's go and have a look in detail to see what this looks like. So this is examples of two heat pumps with the data on our system. So on the left we've got a heat pump from Heat Pump Monitor, and on the right we've got one from the electrification of heat. So both of these heat pumps are exactly the same. They're both 7 kilowatts of Vaillant Aerotherm Plus heat pumps. They're good heat pumps, with generally have good control systems, but we can see here that the differences in how one heat pump is set up does have a considerable difference. Both of these heat pumps over this 24-hour period were running with the same outdoor temperature of 4 degrees, and they both had 21 degrees inside the house. So you can clearly see that the system on the left from Heat Pump Monitor, it's running at quite a low, steady flow temperature, trickling heat into the property throughout the day. In this example, it's running at 32-degree flow temperature, trickling about 2.5 kilowatts of heat into the property, where the system on the right is running quite sporadically. Every time the heat pump comes on, it works really hard to raise the flow temperature up to about 55 degrees, and then it switches off again. That's not the most efficient way to run a heat pump. Low and slow is the best way, and that results in significantly improved performance. You can see on the system on the left achieved a space heating efficiency of 4, where the one on the right from electrification of heat was only achieved a space heating efficiency of 2.6. So it resulted in the well-commissioned system on Heat Pump Monitor using 17% less electricity to deliver 35% more heat. So that's quite substantial. But the good news here is this is just control settings that caused this. So it should be relatively easy to fix if this had been picked up. And this is where monitoring can really help to visualize what's going on and see that there is an issue like that. Next slide, please, Will. So in summary, these are the main things that we've found to, well, improve or avoid poor performance of heat pumps. So in general, simple open loop heat pump systems tend to perform best. Avoid third-party controls. Best to use the inbuilt heat pump controls where possible. Avoid zoning, avoid buffer tanks, hydraulic separation, avoid glycol, avoid hybrid systems, avoid deep setbacks in the schedule. Design for the lowest flow temperature possible. The systems on Heat Pump Monitor averaged a design flow temperature of 40.5 degrees, but many of them are running lower than that. Aim to store hot water at about 45 degrees, maximum 50, with at least 5 degrees hysteresis. Next slide, please, Will. A possible solution to this problem of commissioning is heat pump optimizers. And these are not to be confused with on-off third-party controls. Heat pump optimizers integrate deeply with the heat pump and automatically adjust the heat pump to work well in a specific property. They'll automatically adjust things like the weather compensation, so they avoid the problem with incorrect weather compensation being set up during the commissioning. So these are very promising systems, but I would like to see some more real-world data to prove effectiveness. But I think these could be quite promising solutions, and also manufacturers are improving their control systems as well. Next slide, please, Will. And just to touch on the installation of the heat pumps, most of the systems on Heat Pump Monitor were designed and installed and commissioned by the same. Each individual heat pump, was installed by the same company. So what I mean by that is the same. You don't have a different company doing the design, a different company doing the installation, and maybe someone else doing the commissioning. That's definitely not the way to get a good, conducive to good heat pump performance. You want the smallest gap possible between the designer, installer, and the commissioning, ideally to be the same, same small group of people doing that, so they have full ownership of the system and fully understand every aspect of the design. So avoid subcontracting. I know quite a lot of that happened during the electrification of heat trial, which was probably quite suboptimal to performance. And choose the installer very carefully. In working with good installers is key. It's definitely worth looking for evidence of further training over and above the basic 3-day heat pump courses, and over and above MCS. Look for things like Heat Geek training, presence on social media. If they're sharing their work and engaging technically with other installers, that's a good sign. We've also created a map on Heat Pump Monitor to show the installations over the country, and you can see the performance of every one of those systems and see who installed that system. So it's a good way to find good installers in the area. Have I got one more slide? Yeah, one more slide, please. Well, this is my last slide here. And if you are interested in digging further into the data, you can obviously go on the heatpumpmonitor.org website. But my colleague Tristan Leo and I have also written up in detail the results from Heat Pump Monitor, and going in further details to what makes a good high performing heat pump system. Cool, thank you.
Brilliant. Thank you very much, Glyn. That's really, really useful insights. Really key message as well about how not always, but quite often, some of the differences between low and high performance can be relatively easy to fix, things around commissioning and other control settings. So that's a really, really important message. So I'm going to pass quickly over now to Matt Jones from Bristol City Council. So yeah, he's going to give us his overview of what's been happening in Bristol.
Thanks, Will. Good morning, everyone. So yeah, I'm just going to talk about our experiences over the last few years, learning about everything heat pump and what we're doing to try and increase numbers of heat pumps in our city. So we started a project called OptiHeat, which is about understanding current installation quality, but really importantly, it was what led to that scenario, and ultimately, which we're still working on, is how do we make things better and fix it. Slide, please, Will. So what we identified we needed to do is to get an evidence base locally to understand, what was happening out there across both our own social housing, but also other locally delivered heat pump installations. So we've actually audited, I think we're over 70 now, actually, heat pumps in total across different tenure types. And that's been in partnership with, firstly, MCS, but then local kind of heat geeks, heat geek trained expert engineers to help us to understand how well they're installed and how well they're working. We've been working closely with the University of Bristol to help interview households at the same time to get that consumer feedback. And now we're working with Nesta to do some more audits, some more happening last week, and also to understand what's the cost of fixing or making them work to an acceptable level. Slide, please, Will. So that's just showing the SCOP and on-level heat pumps, which makes them work badly. And you don't need to be a plumber to look at that and go, that doesn't look particularly nice or well installed. So the impacts have been on performance, and Glyn's talked a bit about that. We're seeing quite poor performance, even lower than the MCS minimum. And a lot of these, if not all of them, won't be on smart tariffs. So I know that can offset, but the reality is there's very few people accessing smart heat pump tariffs. And the major issues we'll come on to as to why. So Will, slide, please. So really, I guess, how did we get there? So in new builds, which is a huge area of growth for heat pump installations, there's this flow, which is that often it's a developer-led scheme, so we've got less control on the specifications and that sort of thing. Basically, all roads lead to incompetent installers, unfortunately. So they've not done proper system design training, or found out, very little training being done by people I speak to. There's no specification dictated by the city council, and it literally could be a line saying, in those 10 homes, we'll have 10 times heat pumps, please. It's literally as kind of basic as that in the past. We've got the clerk of works who's signing off the quality of the build, including the heat pumps, who don't really know anything about heat pumps because they're dealing with the whole build. So they're just signing things off, even when lagging's hanging off all over the place and that sort of thing. And crucially, a critical message today is that our officers aren't trained or haven't done enough learning about how to be intelligent clients of delivering heat pump programs. So we didn't know what good or bad looks like. And then lastly, I think this is changing now, but often manufacturers haven't kept a close enough eye on the quality of who they're selling heat pumps to ensure they're competent. Do a click. And then in the retrofit scenario, it's slightly different. Starts with procurement teams. We put in the past that, should be MCS qualified or certified. However, we know across all these installs, a lot of those that we've audited have been MCS installers. We know that MCS, unfortunately, doesn't result in guaranteed quality of install. So there's been the next stage is, again, lack of specification to put into that procurement that's really detailed about what we want and what we expect in terms of outcomes. Often, as I'm sure we'll be familiar, we get mid to large size contractors winning contracts. So on average, and again, I'll keep using that word on average, they're not necessarily doing the highest quality work like we've seen on Glyn's portal there, which tends to be the higher quality installers. poor installation quality, the race to the bottom pricing, no quality assurance undertaken post-install, so no monitoring or no checks, no audits or anything like that. And indeed, households themselves, I don't think, are necessarily aware what good looks like. And I take the feedback that a lot of people do report that they're satisfied because they're getting heat, but actually that's not necessarily giving the entire picture. I'm sure they wouldn't be that happy if they knew they were paying twice the amount of bill than they should be. Slide, please, Will. So this is just a little drop in the ocean. So I see a lot of M&E consultants doing designs, and for this one, it was specified a 5 kilowatt heat pump, when actually this was a 1-bed deep eco building, new build, right? So you could probably heat the place with a candle, and that's got a 5 kilowatt heat pump that might not modulate down sufficiently. And yeah, we're seeing a lot of issues around basically the quality of the install. And if anybody can pick out there, it's being designed at a 55-degree flow temperature, which is really high. If you're doing a new build, you've got the best opportunity there to get the system designed really good to keep the bills down as low as possible. Click, Will, please. So yeah, just highlighting those issues there. So it's already scheduled to perform more expensive than a gas system. Another click. And then actually you could argue that an air-to-air system might be better in that application anyway, where there's such a low heat loss. So it might not even be the right system to start with. Slide, please, Will. There is hope. Glyn showed that it's not the technology, we can do this. Slide, please. So here's some top takeaway tips for you all. It's really important that if you're installing or have installed heat pumps, that you do a quality insurance check now. Go back and look at these and work with local installers to do that, who you can trust. So I'm recommending that everybody does a review while there's still time, because these things could be big liabilities for us all if they're not installed well, fail early, tenants, unhappy, etc. We brought together a heat pump working group internally in BCC, which has worked really well because there's lots of people involved at different stages, whether it be planning, whether it be delivery teams, whether it be the clerk of works, etc., etc. So it's really important to communicate between us all. Get some good specifications. We've got one that I'll show you in a second. You're welcome to use it. It's not perfect, but it's better than we had. Handover documents are really important as well. Like, do some work around that, because it's a challenge. It's a newer technology. I think Glyn alluded to optimizers that can also mean there's less need for, hopefully, households to have to tinker with systems to get the most out of it, because it's done automatically. Review your procurement criteria. Heat geeks generally aren't installing on local authority homes, and there's good reasons for that. How can we break down the barriers for them to get involved in our installations? And lastly, I've learned so much through likes of Open Energy Monitor, the community that Glyn alluded to around those top quality installers, and they do hang out on LinkedIn a lot. They're really happy to share stuff. I go back and forward on WhatsApp messages occasionally with some of them. That's my learning journey. They know what they're talking about, and try and find trusted people to speak to help your own learning journey and initiate that learning journey amongst your colleagues as well. Slides, please, Will. So this was branded up under Healthy Homes Hub because we didn't want Bristol City Council branding on it. But I think the guys here are happy to share that with you all. Slide, please. And that's just like a little dip into what it looks like. So, for example, what are the prerequisites for somebody who's installing for our schemes, and what references and what evidence of competency are we asking for in an ideal world? So I think that was everything. Yeah, I think it's on to more tips, I think, now.
Yeah, that's brilliant. Thank you, Matt. Yeah, I'm going to hand over to Jack now, who's going to try and synthesize some of this into five 5 tips to take away. We've gone slightly over time. I mean, we were very ambitious trying to get all of these amazing speakers into 1 hour, but I think it's definitely each of them has added unique and great value. So definitely glad that we've done it. We may run out of time for the Q&A at the end, but I'd still really encourage you to put your questions in the Q&A function or the chat, whichever is easiest, and we will do our best to kind of get back to you after the event, because we do have a hard stop at 10:30. Over to you, Jack.
Great, thanks, Bill. Morning, everyone. So I'm just going to share 5 practical tips that we think can help improve how heat pumps are deployed, particularly in social housing and fuel-poor homes. I just want to say up front that I recognise that there are lots of considerations when it comes to these kind of decisions, and so there's no one-size-fits-all necessarily. But what we're sharing is intended to be helpful and thought-provoking, kind of in the philosophy or the vein of if Will and I were to specify. Go about specifying heat pumps with an aim of reducing fuel poverty, then these are the kind of things that we'd be focusing on. Next slide, please, Will. So Glyn's already touched on how much heat pump performance can vary, and that's such a key point. And with gas boilers, we've historically been able to just specify the kit and assume it will do the job because the variation in efficiency between installations has been minimal. But heat pumps are fundamentally different. If we want them to reduce fuel poverty rather than risk making it worse, we need to start specifying the outcomes that we want and not just the equipment. That means things like, are tenants warm enough, are the running costs affordable, and are we getting the efficiency that we expected? We're suggesting a more outcome-focused approach, things like guaranteed comfort standards or minimum SCOPs, or even running cost benchmarks where you're also bringing in things like solar and time of use tariffs. But it's not just about setting high bars, it's about how we get there together as an industry. We obviously want to incentivize good outcomes, but we also have to think about how we share risk and collaborate to move forward. Installers are also on their own learning journey with this, and we don't want to create a blame culture, particularly where some of the elements of installs are out of their control. Sometimes it's not about poor installation where we don't see optimal results. It could be how the system's being used by a tenant, or where the delivered performance of a heat pump isn't quite as promised by the manufacturer. So we're proposing things like performance partnerships where everyone's clear on what good looks like and everyone's incentivized to deliver the best outcome. So we think the key is to work together to fix things and not just point fingers. Next slide, please. Qualifications are important, but they don't always tell the full story. There are many installers who are certified but still struggle with some of the fundamentals of low temperature heating system, which is obviously specific to heat pump design in contrast to gas boilers, which have been much higher temperature. Industry experts say that this isn't the fault of the workforce necessarily. They don't know what they don't know. And as a result, training and apprenticeships are being improved as a result to help people coming through in the workforce. But we do encourage you to ask for real world evidence rather than just thinking about qualifications and certifications. So thinking about examples of projects where installers have previously delivered good outcomes, talk to them about if they've studied or have expertise in low temperature heating system design, talk to them about whether they can offer different options that vary the balance between upfront cost and running costs so that they can find a design that offers good performance without overcomplicating things in terms of the installation, the capital expenditure without or increasing the cost too much. So we'd also recommend trying to understand which of the fundamental elements of a good installation the local workforce has competence in. So things like heat loss calculations, system sizing, the handover process, controls integration, and proper commissioning. Next slide, please, Will. Thirdly, installing a heat pump is just the start of the process. If it's not set up and operated properly, then performance can really suffer. So we need to think about things like weather compensation to efficiently deliver on the heat that's needed. Think about smart controls, as has been mentioned earlier in the session, to minimize or even eliminate the mental load for tenants whilst reducing costs, done by juggling multiple different factors like the external temperature, accounting for time of use tariffs, and also potentially accounting for available solar PV generation, trying to optimize for that. And also the potential use of remote monitoring to catch issues early. We'd also recommend thinking about annual performance reviews and proactive maintenance that can incentivize the installer's investment in the long-term performance of the system, and also building trust within the relationship with the installer. Next slide, please. So number 4, engaging tenants early and supporting their journey. This one's absolutely critical. So for tenants, moving to a heat pump often means unlearning what they've always been told about how to keep bills down. Many tenants are used to only heating certain rooms, turning the heating on for short bursts or boosting it when it gets cold. And these kind of practices are actually the opposite of how heat pumps work best. So there's a big shift needed in how people understand and use their heating. And not everyone will be an ideal candidate in terms of their behaviour straight away, which is why we're suggesting tenant suitability assessments up front. That helps us to understand what kind of support will be needed and whether the system is likely to work well for them. Support can't just stop at the installation. We need good handovers, we need practical demonstration of controls for tenants, and need to have ongoing engagement. Things like annual reviews of bills, or even community-based support. A great example of this is the Clean Heat Streets project in Oxford, where they had heat pump champions in the community, helping people to get the most out of their systems. The Clean Heat Streets also found that some people's usage meant that they weren't ready to move to a heat pump, such as where they use such a tiny amount of energy that even a very high-performing heat pump run sort of on a almost constant basis, low and slow, couldn't operate efficiently enough to lower their heating costs or to match it. There's also a wider policy conversation happening in this space. For example, there are proposals around extending the decent home standards so that heating covers the entire dwelling and not just 1 or 2 rooms, which actually aligns well with how heat pumps are designed to operate. The good news is once the system and the optimizer is set up properly, tenants have to interact less with their heating, but there's still an education piece around what not to do, like fiddling with thermostats or switching things off. But it's a fundamental shift. The heating's just on in the background almost constantly, but at low level rather than having sort of spiky on and offs. Next slide, please. So finally, this is a learning journey for everyone. Heat pumps are still relatively new for a lot of people in the supply chain. We're all figuring out what works and what doesn't. So let's share what we're learning, the good and the bad, and collaborate on solutions. There's some great resources out there already. I've come up with a list here of industry insights and support for funding applications that are really helpful. And we at the Carbon Trust are keen to help to keep building that collective knowledge, which is why we're working with social housing providers, including local authorities, as part of what we have as a working title, the Social Housing Heat Pump Delivery Network, which we'll talk a bit about now. Next slide, please. So the Social Heat Pump Delivery Network, what we're proposing is a group of anyone who's interested working in social housing. We are going to have our first session in November at the Elemental London event, and the plan is to meet once a quarter with the objective of sharing practical experiences and lessons learned amongst local authorities and social housing providers to identify and address common barriers that all of you are facing, and then work together to collaborate on solutions and driving action to solve those problems. That's all of my slides. Thanks, Will.
Okay, brilliant. Thanks, Jack. Yeah, I wonder if it's just worth mentioning the partners who've kind of come together to set up the network, including Nathan at Beta Talk and Elemental's role. Yeah, so many of you will be familiar with Nathan at Beta Teach. We actually held our first session at Installer Show in June, where about 10 local authorities came together to share some of these learnings, and yeah, really identified that there's a need and a strong desire for peer learning and sharing experiences and developing common solutions. So yeah, if you'd like further information about the network and what we're trying to do with it, then please do get in touch. Okay, so we do have 5 minutes for Q&A, which is fantastic. I'll just jump straight in with Pete's question about what would be the panel's recommendations for the selection and installation of different heat pump manufacturers across a council housing estate. Yeah, I'll just put that out there. If anybody would fancy having a go at that. Matt, what would be your kind of take and response to that?
Well, the boring line is that obviously we can't recommend any particular manufacturer. So maybe I would talk about more the characteristics of the manufacturers. So what we've had good success with for these audits is where we've engaged with manufacturers, and we've engaged with Vaillant, Mitsubishi, Kenza, a few others. They've all been pretty good, actually, I would say, because they realise that it's their branding on this kit, and in terms of issue resolution and verifying our audits, it's been really helpful to have them. So I think that kind of look, I think installers will have their own views, and Glyn will have some scientific knowledge on which ones on average are performing better. But look, like they're all probably going to perform fairly similar. Like the gap between the gap is the install quality and the aftercare in terms of the biggest impact in my view. And glad to see Glyn nodding at that. So yeah, try and get a feel for how responsive are, and again speak to try and find good quality local installers, and they'll give you a sense of what service level they get from certain manufacturers. Can they get parts? That's a huge issue potentially in the future. If a heating system goes down, gas boilers, worst case, we can swap one out in a few hours. We can't do that so well with heat pumps. So supply chain is going to be really important. And I think one thing we're moving towards is more of a sole specification, or vastly reducing the number of different brands that we work with just for the service side, because our maintenance teams have got to learn about all these different systems. And clearly, if that's fewer systems, that's easier to learn and maintain going forward.
Yeah, no, that's great. Anything to add to that from any of the panel, Glyn?
Yeah, we've seen good performing heat pumps from every make and manufacturer. So the design, what we've seen is the design of the heat pump and the installation of the heat pump and the commissioning of the heat pump has a much greater effect on the overall performance than the make and model of the heat pump. That said, some heat pumps are more forgiving. Or it's easier to make them work well, basically, if they've got a good control system. So yeah, if you have a look at Heat Pump Monitor and have a look at the top performing systems on there, you can get an idea of the sort of heat pumps that installers like to install heat pumps that are easier to work well, and those are the systems that have are dominating the sort of highest performing systems on there.
Yeah, brilliant. Thanks, Glyn. I'll just finish with a hopefully relatively straightforward question from Matt Aylott from Richard McWilliams about how much of the Warm Homes Plan will apply in Scotland, Wales, and Northern Ireland. For example, the talk about rebalancing electricity costs and supply chain support.
Yeah, it's a good question. So, I mean, much of the Warm Homes Plan will be applied across Great Britain, not necessarily United Kingdom. Some things like grants are only available in England or England and Wales, but things like rebalancing will certainly apply across GB.
Okay, brilliant. Good, concise answer. On that note, it's 10:29, and I know everybody's got very busy days and busy schedules. I'd like to thank all of our speakers who've come and given us really great insights today on this really critical challenge. As has been said in the chat, all of this will be available on our website, recorded, including the slides and the recording. Really hope that some of you will get in touch with us about the social housing heat pump delivery network that we're going to start meeting quarterly to discuss these issues more and identify common solutions. So with that, I'll say thank you very much and goodbye. Have a good day.